Okay, let's do this. Time to talk about significant figures. Significant figures are going to be with you through the entirety of chemistry. So, first thing you need to understand, significant figures are round because of measurements. Because you measure on different instruments, you want to have consistency in your responses. You want to make sure that measuring is as close as possible to one another based on your accuracy for significant figures. First, let's look at the rules. There are several rules that indicate when zeros are significant and when they are not significant. So let's start when they are significant. All counting numbers are significant. So 1, 2, 3, 4, 5, you can count. Those are going to be significant figures. If you have a counting number in a measurement, it is significant. Next up, you have zeros in between counting numbers. So if a zero falls in between a counting number, whether you have 1 0 in between a counting number or 2 zeros in between counting numbers, those zeros are always going to be significant. You have clear indications here, clear examples here: 105, 2025, 2003. All of those zeros in between the counting numbers are significant. When a zero is at the end of the number with a decimal, they're called trailing zeros. And those trailing zeros actually give you exact measurements. So, depending on how accurate your instrument is, determines how many zeros you will have at the end of your decimal. But all those zeros will be significant. So, here you have 10 with a decimal, 0, 1.00, 15.00. You have 100 with no decimal, meaning it's exactly 100. Those are all significant zeros. Next, you have coefficients for your scientific notation. Coefficients for the scientific notation will always include significant figures. So if you have 1 0 behind the decimal or 2 zeros behind the decimal, those digits will be significant. Okay, so here's where we deal where zeros are not significant. When a zero is the beginning of your number, it is not significant. So if you have 0.05 or 0.002, those zeros are not significant. You do not begin a significant figure until you get to a counting number. Leading zeros are not significant. Likewise, when you have a large value, a large number, the zeros at the end without a decimal are simply placeholders. So think of estimations. If you have a large value number with just zeros, those zeros are not significant. It's just for placeholders. All right, let's look at some examples. Like I said, significant figures are going to be around for the entirety of the course. The best way to learn them and become good at them is to continuously practice them. So let's look at these examples. Like I said, it's a determining significant figures for the measurements. You're dealing with measurements. Let's look at these examples and determine how many significant figures are in each of these measurements. So for 20.0 kilograms, you have 3. 300 centimeters, 1. 146.8 Kelvin, 4. 109 milligrams, 3. This volume measurement, 3. And the last one, 2. One of the main reasons you deal with significant figures is because of calculations. You want your measurements to be calculated based on the accuracy of the instruments. And so you have a couple of rules that you need to follow. The first one is multiplication division. And we do that first because it is most often used in chemistry. Rule says the fewest digits will be your final answer. In our first example, again, we're going to assume that they're all measurements, but in our first example, when you do the math, you actually end up with an answer that has fewer digits than you want. So you're going to have to add zeros. You add zeros to have 3 significant figures, and this is your final answer. Did you get it? What about the next one? How many sig figs did you want? That's right. And so your final answer? You got it. Great job. All right, let's move on to addition subtraction. Not used often, but it is used. And the rule simply states that the fewest digits behind the decimal are how many digits you should have in your final answer. So it doesn't matter how many numbers you have before the decimal, what comes after it tells you. So once you line everything up, the fewest numbers behind the decimal is how many? All right, so that means your final answer is, that's it. Chemistry is all about practice. So take some time, practice these next ones, see if you get the answers correct. The most efficient way to do this is to look at the type of calculation you're going to perform, determine the rule, see how many significant figures are in each of the numbers you're going to calculate, and then determine how many significant figures you need for your final answer. Go ahead and try it. Let's see what you got. Did you get it? I knew you could. Go ahead and try the one at the bottom. I'll wait. How many significant figures do you need? Remember the rule. Okay, so you did the calculation. And what's your final answer? Okay, good job. What about the top? How many significant figures do you need in your final answer? Sounds good to me. Okay, you're doing great. Do the last one. Good job. If you want to keep practicing, remember to subscribe and come back. Bye.